Hi everyone, welcome to Algebra of Functions Day 2. So today we'll continue to combine functions using algebra here. And today we'll focus on division. So the question's giving you that is f of x is x plus 3, g of x is x squared minus 9, and h of x is x minus 4. So the first question asking, what is f over g of x? So here they're telling you f over g of x. So now let's break that down as f of x over g of x then. After we have broken down to two different functions, let's plug it in with the actual equations here. So the f of x is giving you that is x plus 3. So why don't we just put that in? And the g of x is x squared minus 9. So from here, we know the x squared minus 9, we can actually factor that out. So x squared minus 9 is that binomial perfect square one. So let's break that one down. So x squared minus 9 is same thing as x plus 3 times x minus 3, right? So if we factor the x squared minus 9 is x plus 3 times x minus 3. And then I'm going to keep that x plus 3 then. So for here, now let's figure out, using the rationals, can I cancel anything? Then you will realize that I have x plus 3 top here, and then x plus 3 is also down here. So I can cancel that out, which end up giving you 1 over x minus 3 then. So that will be your final answers. However, please don't forget about the restriction. Now we're talking about fractions here. So we have the restrictions in denominator. So for restriction, x cannot equal to negative 3 and also positive 3. So the negative 3 is coming from here, and then positive 3 is coming from here. So please don't forget about your restriction. Let's continue. Now let's look at this second questions here. So they're telling you h over g of x, which I'm going to break it down as h of x over g of x. So h of x, I can rewrite that as x minus 4, and g of x, which is x squared minus 9. So from previous questions here, from question 1, I can't factor the x squared minus 9 as, once again, x plus 3 times x minus 3. And I'm going to keep my x minus 4 in my numerator. This one, you notice I can't cancel anything out, so that's actually your full answers. Also, don't forget the x cannot equal to positive 3 and negative 3 as well. All right, let's look into, or let's continue with more examples here. All right, so let's look at g over f of x then. So I'm going to speed up a little bit. So I can rewrite that as g of x over f of x then. So I know g of x is x squared minus 9. That should be on the top. F of x, which is x plus 3, on the bottom. I'm going to continue factoring the x squared minus 9. So that's same thing as x plus 3 times x minus 3. And everything over x plus 3. So once again here, I know I can factor out, or I can cancel, the x plus 3 and x plus 3 then. Which means I will have the solution of x minus 3. That's the only thing it will remain. So here's my solution. Also for this one here, the restriction is that x cannot equal to -3 then. All right. Now let's evaluate. So let's review just evaluating the functions again. So here's is giving you that f of x is 5x plus 2. The question is asking for first one is what's f of 5? So in order to do that, all you have to do is plug it in. The 5, substitute the 5 as your x. So I'm going to rewrite the 5x plus 2, the function again, as 5x. Instead of the x, I'm going to put parentheses right away, plus 2. So for this one here, I'm going to replace the x as a 5, like so. And just calculate it out. So 5 times 5, which is 25, plus 2, which end up giving you 27 as your answer. So if I'm asking you to put the answers as an order pair, it'd be 5, 27 as your final answer then. All right, let's look at what's going to be my GF of 6a. So same thing. I'm going to write down the 5x plus 2, and instead of the x, I'm just going to put parentheses around it. And then for here, let's substitute the x as 6a right here. So all I'm going to do is multiply the 5 and the 6a, which end up giving you 30a. And then plus 2, that should be your final answer. All right, let's keep going. So I'm looking for f of a plus 2. Then, same thing, 5 parenthesis plus 2. So once again, every time I see an x, I'm putting parentheses around it. I'm going to replace the parenthesis with the input of the function, which is going to be the a plus 2. After I have done that, I'm going to distribute my 5. So you end up getting 5a plus 10 plus 2. Then I can combine these two here, so you end up getting 5a plus 12. Now let's look at this one here. I have f of a minus 7, which is 5. I'm going to replace the x as a minus 7 plus 2. Same thing. I'm going to distribute my 5. So I got 5a minus 35 plus 2. So I end up getting 5a minus 33 as my answer then. Alright, so what I want you to do is maybe pause the video for a little bit. Oh, here's my pretty version of the paper. Then, can you please work completing on that Algebra of Function worksheet and complete 13 to 18 for me. And then I will still continue with the video though. So just pause it for a second, work on that questions, and let's continue. Alright, let's continue with this one here. So now let's add some of the functions. So the functions given to you is that f of x is 1 plus 3x here. And then first question is asking f of 5a plus f of 3. So in order to do that is you need to figure out what f of 5a is going to be first. Also figure out what f of 3 is going to be and just combine them two. So let's continue and look into what f of 5a is going to be first. So here, the 5a is going to be, put it in there as your x. So it's going to look like this. 1 plus 3x, and instead of the x, let's put in 5a. So this is telling you what the f of 5a is going to be. let's add that with f of 3. So it would be 1 plus 3 times x one more time, and instead of the x, let's plug it in the 3. This section's right here. This will tell you what f of 3 is going to be. So let's calculate it out. So this one here is going to give you 1 plus 15a. And then the f of 3, if you calculate that one out, you end up getting 1 plus 9. So which end up giving you 10. Then I'm going to combine my like terms, so you will see my constants. I'm just going to combine them all. So your final answer should be 15a plus 11 as your final answer. All right, let's look into the question number 2. So this one's telling you f of a plus 2 plus f of a. So let's focus on the f of a plus 2 here, which is going to be 1 plus 3 times a plus 2. So once again, besides putting in the x, I'm going to put this right here, a plus 2. So this section is telling you what f of a plus 2 is going to be. Plus, let's figure out what the f of a is going to be. So that's 1 plus 3. Instead of the x, I'm going to plug in the a. All right, so let's continue to simplify further with this. So first step, I'm going to distribute my 3. So this one end up giving you 3a plus 6. And I'm going to keep my 1. And then here on the f of a, that will simplify just as simply as 1 plus 3a then. Alright, so I'm going to combine my like terms here. So I'll combine my a's first, which end up giving me 6a. And let's combine my constants right here. So that will be giving you plus 8 then. And here's my final answer. Alright, let's look into what f of a plus 8 minus f of a is going to be. So that's going to be 1 plus 3. Instead of the x, I'm going to put a plus 8 minus, this was giving you what f of a plus 8 is going to be, minus f of a, which is 1 plus 3a. First step, I'm going to distribute my 3. So you got 3a plus 24. And I'm going to keep my 1 right here. Since it's a minus 1, or technically I have a technically negative 1 here, I'm also going to just distribute my negative 1 right away as well. So this ends up giving you negative 1 minus 3a then. Alright, same thing, I'm going to combine my like terms. So here's my 3a minus 3a. And you will notice that cancels each other out. So you'll be left with just the constant, which is 1 plus 24 minus 1 here, which will give you 24 as your final answer. Alright, let's look at question 4. That one looks a little complicated, but it shouldn't be that crazy. So first step, let's figure out what f of a plus 4 is going to be. So that one here is going to be 1 plus 3. For x, I'm replacing as a plus 4 here then. So this is representing f of a plus 4 minus f of a, which is 1 plus 3a. And I'm going to divide all of that by 4. Alright, I'm going to distribute my 3. So I got 3a plus 12 here. and I'm going to keep my 1. Same thing, I am going to distribute the -1 here, same thing, like so. Oops, excuse me. So this will give me -1 minus 3a on the top. I'll keep my 4. Then you will notice my 3a minus 3a cancels out. So you're left with just the constants on the top. So you end up getting 12 on the top. Keep the 4. And 12 over 4 is 3. So 3 should be your final answer then. I'll continue. So this one here, they're asking what if I have f of x equals x 4x, then I want you to evaluate that f of a plus h minus f of a over h. So let's look into this one real quickly. So for here, let's focus on what f of a plus h is going to be. That's going to be 4 times, instead of the x, I'm going to put a plus h. So this section right here is telling you what f of a plus h is going to be. Minus f of a, which is going to be 4a. And I'm going to divide all of that by h. Then I'm going to distribute my 4 here. So end up getting 4a plus 4h minus 4a on the top and h on the bottom. Then you will notice my 4a's minus 4a cancel each other out. So you're left with 4h over h. Then you notice I can cancel h one more time. So you get 4 as your solution. And these equations is a very important and useful equations that I will expect you to know and memorize. So we're part here. I call that the difference, or we call that as a difference quotient, which is f of a plus h minus f of a over h. This is the function that will be very helpful, so that I want you to know how to use it. So knowing these equations here, let's try a couple examples using that. All right, so first thing here, I have f of x equals 2x plus 5. And let's use the quotient rule here. So the difference of quotient is that f of a plus h minus f of a over h. Then what I'm going to do, plug it in here. So I'm going to have f of a plus h is 2 times a plus h. So once again, I'm replacing this here, that's your x, with the a plus h, and then plus 5, minus 2a plus 5. Then I'm going to distribute my 2, so you got 2a plus 2h plus 5. Then I'm going to distribute my -1 like so. So I end up getting -2a minus 5. Then you will notice my 2a's cancels out. My 5 cancels out. So you're left with 2h over h. Then h will cancel out again. So you end up having 2 as your final solution. All right, let's look at question number 2 here. So the equation is telling you is g of x is 5x squared plus 3. So, once again, I'm going to use my different quotient. So according to the difference of quotient, I'm going to first replace my x as a plus h square. And then right here, same thing, my x as a here. Then, please make sure when you're doing this, you need to square that 2. So always remember, a plus h square is same thing as a plus h times a plus h. Then you can use your perfect square formula if you want, or you can just make sure you can distribute like so. So if you do that, you'll end up getting a square plus 2ah plus h square. So if you're distributing, or double distributing, so you're foiling here this part, this is what you end up getting. Let's continue. I'm going to distribute my 5 like so, and also I'm just going to distribute my -1 here as well. So this is what you end up getting, 5a squared plus 10ah plus 5h squared plus 3 minus 5a squared minus 3, everything over h. And you notice I can cancel a lot of things here. 5a squared, that cancels out. 3a cancels out. So you end up having 10ah plus h squared. Then you will also notice I can cancel all my h's here. So your final answer should be 10a plus 5h. So I want you to begin working on difference and quotient worksheet, and we'll go from there. I'll see you in the next video.